we are going to cover exterior angles of triangles. Our learning target for today is I can use equations to find missing angle measures of triangles. Looking at exterior angles of triangles. So an exterior angle is formed by one side of a triangle and the extension of an adjacent side of the triangle. So in my figure to the right, I have angles 1, 2, and 3 on the inside of the triangle. These are interior angles. Then I have an extension of the triangle here with angle 4 on the outside. So angle 4 is an exterior angle of my triangle. Now, remote interior angles are the two interior angles that are not adjacent to or touching the exterior angle. So if I look at my triangle here again, angle 4 is my exterior angle. Angle 3 is right next to that exterior angle. So my two angles that are not touching angle 4 would be angle 1 and angle 2. These are my two remote interior angles of angle 4. So angle 4 is the exterior angle, and angles 1 and angles 2 are the remote interior angles. Now looking at a theorem of exterior angles, we have triangle ABC as shown below. Is there enough information to find the measure of the exterior angles? If so, find the angle measurements. So I want to find the angle measurements of angle 1, angle 2, and angle 3. Notice angle 1, angle 2, and angle 3 all make straight lines with angle A, angle B, and angle C, respectively. So if I take 180 and subtract it from each of those angles, I'll get the angle measurements. So angle 1 would be 130 degrees, because 180 minus 50 is 130. Angle 2 is 110 degrees, because 180 minus 70 is 110 degrees. And then angle 3 would be 120 degrees, because 180 minus 60 is 120 degrees. Now, if I look at the two remote interior angles with the exterior angle, I can find a correspondence. Now looking specifically at the interior angles of my triangles without the exterior angles, if I find the sums of angles A and B, that's 120 degrees, because 50 plus 70 is 120 degrees. Notice when I add in my exterior angle of angle 3 is the same exact measure of angle A and angle B. If I find the sums of angle B and C, that's 130 degrees. 70 plus 60 is 130. That is the same measure of the exterior angle of angle 1. If I find the sums of angle A and angle C, that's 110 degrees, because 50 plus 60 is 110, and that's the same measure as the exterior angle, angle 2. Which leads me to this conclusion: any exterior angle is equal to the sum of its two remote interior angles. This is the exterior angle theorem. Looking at this in some problems, when I have two remote interior angles, I can add these together to get me my exterior angle. Or if I have the exterior angle and one of the remote interior angles, I can get the other remote interior angle. So looking at number 2, I want to find the value of x. I have 54 degrees in x as my two remote interior angles, and I have 115 degrees as my exterior angle. So the exterior angle will equal the two remote interior angles. If I subtract 54 from 115, I'll get x is equal to 61. So x is 61 degrees. Now, if you don't believe this, 115 degrees and let's say angle y make a straight line. So angle y would equal 65 degrees, because 180 minus 115 is 65. Now I have three angles inside my triangle. I can say that 54 plus 65 plus x would equal 180. 54 plus 65 is 119. So 119 plus x equals 180. Then if I take away 119 from 180, I get 61, which is the same thing as if I used my theorem where my two remote interior angles will equal my exterior angle. Looking at number 3, again, I have an exterior angle of x, and I have my two remote interior angles of 66 and 50. My theorem states the exterior angle will equal the sum of its two remote interior angles. So x will just equal 50 plus 66. So the x is 116 degrees. Now looking at some examples where I have expressions instead of just numbers, I have triangle DEC, I have remote interior angles of D and C, and an exterior angle of angle CER. I want to find the value of x and the angle measure of REC. Again, I can use my theorem. The exterior angle of a triangle will equal the sum of the two remote interior angles. So 4x plus 10 will equal 2x plus 70. Now solving this equation, I'll subtract 10 from both sides. So 4x will equal 2x plus 60. I'll subtract 2x from both sides. 2x will equal 60. I'll divide everything by 2, and x will equal 30. Now that I have x is 30, if I want to find angle REC, I find my angle measures by following the path that the three letters takes me. So I'd start at R, go to E, then go to C. Notice that makes this angle here, which is 4x plus 10. I know that angle REC is the expression 4x plus 10. So 4 times 30, because we will replace x with 30, plus 10 will equal angle REC. 4 times 30 is 120, plus 10 would be 130. So angle REC is 130 degrees. Now looking at number 5, I have triangle XYZ with two remote interior angles and an exterior angle. Again, using my theorem, the exterior angle of a triangle is equal to the sum of its two remote interior angles. I can set up an equation. My exterior angle is 14x plus 3. That's going to be equal to 5x plus 2 plus 5x plus 33. If I combine like terms, 5x and 5x will make 10x, and 33 plus 2 will equal 35. Now solving this equation, I'll subtract 3 from both sides. So 14x will equal 10x plus 32. I'll minus 10x from both sides. 4x will equal 32. Divide everything by 4, so x is 8. Now that I have x is 8, I want to find angle BZY. Again, start at angle B, go to Z, go to Y. This shows me that this angle, 14x plus 3, is angle BZY. Angle BZY being 14x plus 3, 8 will take the place of x, and then I will add my 3. 14 times 8 would be 112. 112 plus 3 would be 115. So angle BZY is 115 degrees. In today's lesson, we learned the exterior angle theorem, which is the exterior angle of a triangle is equal to the sum of its two remote interior angles. That's a wrap on this video. We'll see you in the next one.